this class. I like it. Good point, though. You gotta be really careful about what your population is to talk about good or bad samples. So my population is you guys, because I want to say something about my class, and I just pick a few rows of people that I can kind of say that's representative, because that would be a cluster. All right, you guys semi with me? Maybe. So real quick story about the cluster. By the way, this is how cluster works. Clusters all from some. Look at these very useful, quick ways to say sum from all is stratified. I'm trying. And then the other one is all from some. That's got to be cluster. When I hear cluster, well, first thing I think is cluster F. It's just a cluster. But I also think about like cereal, honey nut clusters, and you get the whole cluster, right? So cluster is you get the whole row, and this whole row. Stratified is across all the strata. I'm trying to get it in your brains. Okay. Yes.
Cluster random as well.
Totally. Because again, I randomly picked rows, so everybody had a chance. Now, real quick question, story. Somebody in the military one semester said, cluster sucks. I know from experience, cluster's bad. So stop teaching that shit. I'm like, whoa. Tell me how you really feel. So I asked him what happened, and he's like, okay, after they went into Iraq and took Baghdad, it was a few months after that, they wanted to get a feel for how conditions were in the different areas of Iraq. You guys with me? So they broke up the areas they broke it up into little areas, right? And to do cluster, what would you then do? You would then randomly, like throw a dart, and then go take everybody from those areas, right? To do cluster. What did they do? They said, well, this is dangerous. Let's not go there. This is actually what happened for this one study. Let's not go that's dangerous. Let's not go there, it's dangerous. Let's pick from the remaining ones. So of course, what did the report look like? Did the report accurately portray the conditions? Because they didn't go to the worst part, so of course the report's going to be better than it should have been. You guys kind of with me? Nothing against Iraq. We went in there and screwed shit up. But we went in there and we selectively said, look, they're doing great. So then I explained it to him and I understood. It's not cluster's fault. It was the humans misapplying cluster.
Misapplying the way it works.
Beautiful. Didn't do it correctly. They didn't do the first step right. Pick randomly. They didn't do that. They had bias. So that's where it died. Okay, I like it. So that was kind of cool that came up. Okay. Any questions about this so far? We got one last one left. And it's the easiest one, actually. I can't remember. I might have used this word when I said you guys were a sample for the whole population of Grossmont because you are convenient. I didn't even try to make it random. That's what convenience means. If you don't even try to make it random, that's a convenient sample. It could be a good sample, but I gotta just ignore it because you didn't even try to make it representative. So the name makes sense. Sometimes math people, we call things something that makes sense. Every now and again. So convenience is exactly what it says. It was convenient. You didn't even try to make it random. So you gotta, if it's a convenient sample, you don't trust any results from it. So some doctor said, yeah, I talked to 1,000 people, but they're all patients that I like. And I found, no, I don't care what you found. That's convenience. They're your patients. You probably took them when they came in. I like you. Okay. What do you think about how oh, really? You think I'm really great? This makes, right? I'm not going to trust anything. Maybe it's true, but I can't trust it. Yes?
So is that the only not random?
Like I said earlier, if you misapply these, they could be. But if they're applied correctly, these are all random. Truly random. That's the one I can't trust. That's why I put it over by itself. Bad. Bad. Okay. Okay, maybe. All right. There is one more thing in chapter 1 that kind of bleeds over into chapter 2. So we're going to do that and try to stay on pace with my other class. And then as soon as I get through that to a certain point, we're going to take a little field trip. Okay. Oh yeah, we got plenty of time. I love it. Oh. Everybody got this stuff? Okay. One semester, there was always some girl that would go, wait, just joking. Shut up. All right. When I say, so I'm gonna kind of go into chapter 2 because if you've done any of chapter 1 homework, I don't know if any of you guys have hit the frequency tables yet or the, not yet. Okay. So this is gonna talk about that idea. If I say bar graph, do any of you guys get a picture in your head what a bar graph looks like? What's it look like? It's got bars. I like it. That's a good first thing. But notice something. Bar graphs always have qualitative data. Or if it's quantitative, it's just labels. So women, men, right? So can there be a gap? Of course there could be a gap. This is women, and this is men. Does that mean anybody is missing in the middle? Now, I don't want to get, I'm sorry, maybe this is not the best example. We'll say this is the only two things that people identified as. So have I missed anybody? No. So this gap doesn't mean that there's an empty class. It just means it's in between the two groups. There's another kind of thing that looks like that, but it's called a histogram, and it works with quantitative data. Quantitative. Right? Works with quantitative data. Which means this is going to be a real scale. Numerical data. So it could be, ages in a class. So it could start at 16, go up to 80. Right? You guys kind of with me? That's what it would look like. So what would it mean if there was an empty spot here? So what this ship would this mean? I don't freaking know, but let's say this is 20 here for somehow. What would this mean? This would mean that there's nobody in between those ages. So a gap actually means something then. You guys with me? So there can't be any gaps on a histogram unless there really was nobody there. So in a college classroom, if this was 35 to 40, could there be nobody aged 35 to 40? Yes. So maybe there's an empty class there. There's nobody that was 35 to 40. Normally down here, this is never going to be empty because most of you guys come right out of high school. Can't like it. Some of you guys are like, high school is a distant memory, Joe. Okay, I understand. Maybe. So this is the kind of picture that we are going to create just given a set of data. So notice something. Let me put this back up. Let me see if I can work with this directly. I want each rectangle to be the same width. You guys with me? How many rectangles are up here?
5 by 5.
There's actually this empty one, right? So I'm sorry. How many classes are there? There's 1, 2, 3, 4, 5, 6. I like it. You guys with me? This is actually less of it's a mathematical thing, but it's actually a very physical thing too. If I gotta go from 16 to 80 using 6 bars, that's a physical idea. How wide must each bar be? You guys with me? So I gotta go from 16 to 80, and I'm gonna use 6 bars. How wide must each one be? So let's do this. Let's say this is the 16 mark, and this one is the 80 mark, way over here. You with me? And I like the 70, so I want to put beautiful wood paneling up there for some reason, so then I can't write anything, but too bad, it's going to look really nice. We're just going to sit here and stare at it. And I'm going to use 6 panels. Now, some of you guys, anybody ever done any construction? No. Yes? So this should feel like something that happens every now and again. You got to figure out how wide something's got to be to fit into a certain area. So first off, what's the very first thing you're going to figure out? I want to know how wide each bar is to be so I can go from 16 to 80. Well, how far do I have to actually go? How wide is this total? 64, I think I hear. So 80 minus 16, 64. This is called the range. The range is high minus low. This is how far your data ranges, right? So I got to go 64. And I'm going to use 6 panels, which is the same thing as these bars. So how wide would each one have to be to cover that? You could do this. So, another way to look at this. How wide would each step have to be so that it takes me 6 steps to get to the end? How wide would each one have to be? Distance divided by 6 to see how much of that distance each step gets. Distance divided by 6 to see how much each bar gets. So I'm trying to make this formula make you realize how it makes physical sense. It's not just pure math. No math is actually pure math, but it makes physical sense. So the width of a class is going to be the range divided by the number of classes. And in this specific example, that would be 64 divided by 6. Now, of course, 64 divided by 6 doesn't go in evenly. What do you get? 10.6, right? You always round that number up because we want to overcover instead of undercover. So I would round this up to 11. So that would be my class width. Okay, stay with me. All right, so I'm going to make up some data, and then we're going to work with it. We're going to create a histogram, and then that's all we're going to do today. So I feel like that's enough. You guys got this here? Oh, yeah, for somebody. All right. So let's do that one with ages of people in a classroom. So I have had 16-year-olds in a class before. Sure, I like it. So go ahead and write that down, unless you don't want to take notes. It's up to you. Yes.
I'm assuming for that type of problem, it wouldn't make sense, like if we were to do an actual survey, because then if everyone was close to the same age, would that still work? If there was
That's a good point. So that's why the reason I do this, so there's several different ways to represent data. If I had nothing but 16 and 17 and 18 and that's it, then this histogram would be kind of stupid. Right? You wouldn't do it that way. There are other ways to represent that data then. So a histogram doesn't always work. If there's a bunch of repeats and only a few values, a histogram is not going to tell you shit. So you wouldn't use a histogram. So it's a good point. So this is the first type of visual representation of data that I'm going to show you. And then we're going to do several others. Yeah. Yes?
The number after the 19, is that 20?
That's a good question. This one? 20. Poor little number. Okay. So what's the range of this data?
16 to 41.
Good. So the range itself is a number. It's not the interval, it's the number. It's the difference. It's how much it ranges over. So of course that would be 25. Okay. I like it. Let's go ahead. Well, let's see. Here's a little note to take. The number of classes we're going to use will be at least 5 and at most 10. Less than 5 is not good enough resolution. More than 10 is insane. It's like every data point gets its own class then. How good is that? So don't use 4 classes. That's a quick way to lose points on this kind of problem. 5 up to 10. Normally we're going to use 5 or 6 because I'm not going to give you 100 data points. Then you could basically, you almost could slap me in the face and say, what the shit? Because that's just busy work then, really. But that actually is true data. You're normally working with thousands of data points, and that's when computers do all this shit for us. So if I'm going to use, let's use 5 classes so I can show you what happens here. What would the class width be?
5.
Yeah. It's going to be range divided by the number of classes. Out to round that at all, it's a nice whole number. So if I would have gotten 5.2, you would round up to 6. So when I say round up, I don't really mean round. It just means force it up because you want to overcover. If you undercover, there's some data points that have nowhere to go. Oh, so you want to overcover. Okay, maybe. You guys doing all right? So this isn't too intense yet, but at least it's not definitions, right? Some of you guys should be like, oh, I can sink my teeth into this shit. I can divide. All right. Might just be. I don't know. So now we're going to create our classes. I'm going to show you the book method first, and then I'll show you the way I was taught. And I don't care which way you use. You're not going to get, oh, you use my way? Oh, no, you're going to get bonus points for that shit. I'm going to try to show you how the way I was taught is better, but I'll start with the book method. So what data point? I should start at 16. You with me? You could start at 15, but let's just start at 16. So there's some flexibility in how you set this up. So if the first class starts at 16, so again, this would be like 16 up to what? It's kind of related to this. It's not going to end up looking like that, to be honest, but that's basically what it's related to. If the first class starts at 16, where should the next class start?
18.
How wide is each class? 5. So if the first one starts at 16, the next one should start at 21. Okay, good. Right? Not a big deal. Let's just keep adding 5. Can you do it, Jeff? Maybe, I don't know. 1, 2, 3, 4, 5. Okay. Now it's going to go up to something, right? It's going to be some range. What's wrong with me? Of course, I didn't make anybody 21, but shit. What's wrong with me? Did I make anybody? Yes. Like, for example, right here. What would be wrong with me putting 31 there? Why is that wrong?
The next class.
Now watch. Is there a 31-year-old? What class is he going? Can't be both. All right, so that's why the textbook method, here's the first little thing that's bad about it. I don't put 21 here, I put 20. 25. This is the book method. Sorry, yeah, thank you. The book method has a few things that are a little freaky that you have to adjust for. My method don't have none of that shit, so we'll see. Again, I don't care which way you do it. Now eventually, now watch, I just want to show you one other thing. What did I say can't happen on a histogram that can happen in a bar graph? Gaps. Mind the gap. So, if I start to do this 16 to 20, 21, do you see how I'm going to have gaps, right? If I do that. Okay, now again, it's the book method. If the book didn't teach this way, I would never teach it this way, but it does, so I give it to you as an option. So here's the first problem. And this is going to sound really weird, like a lot of shit I say. But there's a limit to me, right? There's a limit to Jeff. I stop right there. This is where Jeff stops. So these are the class limits. Then there's a boundary that if you stand closer than the boundary, I better know you really well, or else we probably have an issue. You with me? So there's a boundary that I'm okay with you being close to me, depending on how well I know you. Right? Turn around, you're right there. Okay, dude. You're in my boundary. The boundary here would be 15.5 to 20.5. So where's this one start? You can do it. So I went down by half, up by half. down by half. See how these would match up now? When I go to graph it? So the actual thing would look like this. 15.5 to 20.5. And then the next class immediately starts and goes up to 25.5. Okay, maybe. So now, with those, can you see how far apart are these? 5. Then you can see the width. Okay, so now maybe you understand why I don't like. Now here's why students don't use the other method, which is easier, but unfortunately it's got some symbols some students don't like. So here's what the other way would do for this. This would look like this. 16 less than or equal to x less than 21. 21 less than or equal to x less than 26. And so forth. So people don't like x, people don't like inequalities. But where would 21 go? Which class? Second one, because this one can't equal 21, can it? My class limits are equal to my class boundaries. These would be 16, 21, I think. Yes. Gotcha. You guys see what I'm saying? Textbook way is this way, but then you have to worry about the limits and the boundaries. Or my way, you don't have to worry about that, but you got to be comfortable with inequality symbols and stuff, which hopefully most of you are. So I don't care which way you do it. You pick a way. Okay, maybe. So what's the next step now? So you don't have to write these up there. I just did that so you can see what it's going to look like over there. The next step is to count how much shit happens. The frequency is how frequently a data point shows up in that class. So how frequently did I see somebody age 16 to 20? Seven. I like it. Yeah, just count. You just tally. Hey, Mr. Tally Man. Tally me bananas. So 21 to 25. 2. 26 to 30. 1. 31 to 35. 2. 36 to 40. 1, but here's the thing. Anytime, I wanted to show you this. Anytime your class width isn't a decimal, you're going to have this one little data point that sort of escapes. So this is the one time you're allowed to do this and suck that dude in. He's right next to it, so it's just like a little thing of mercury, just sucks it back in. Or like the advanced Terminator sucks that back on his shoe. Right. Or whatever you want to look at. That's the one time you're allowed to break the width, is to suck in that last data point. So now it is 2. And there were 14 data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes. And that's good because my frequency adds up to be 14. So please, dear God, if this adds up to be 13, you got to check it so you know if you left some poor thing out. Thankfully, you have a teacher that gives you partial credit. So if that's the one mistake you make and everything else is right, I'm just going to take points off for the one mistake. Yes? I'm gonna freak you out a little bit. You ready? How many numbers 16 to 20? 16, 17, 18, 19, 20. I'm sorry. But also, that's not even really the answer, but I just love doing that to people. Right, there's 5 numbers from 16 to 20. You with me? Yeah. But more importantly, you don't see the width here. You see the width here. Right? That's where you see the width. So the textbook method, the way that most books for some reason are doing, even though this way is better, is this way, which hides the width. So you can only see the width. That's why I do 16 and then start the next one. 5 away. 5 away, 5 away, and then these will be 1 less, 1 less, so there's no overlap. So they each have 1 home to live in. Not 2, yeah. Somebody? Yeah. Okay. Again, how many times have we done a problem like this? We're not even done with this one, so like half of the time. So give yourself a chance to have it sink in your head. You don't have to know it the minute I say it, thank God, right? Holy shit. Okay, we're almost there. Humans developed, well, they developed every freaking thing, but they developed this idea of percentages because percentages give us a better feel for how much of the whole something is. So if I take each frequency relative to the total amount, math people being creative, we went, let's call that relative frequency. So that's what it is relative frequency. And when you see that, you just think percentage. So how do I figure out what percentage is in this first class? 7 out of 14. Yeah, which is 50%. Yeah. What about 2 out of 14? Believe it or not, I think that comes out to be almost 14%. Yeah, it's like, I don't know, I've lost it. Anybody gonna do that for me?
Yeah.
2 divided by 14 should be like
We use it 2 divided
2 divided by 14, right? 14.2%. I'm a math person. I should know some of this shit. Right? I know some shortcuts for dividing shit. 1/14. So that's going to be roughly 7.1%. It's half of that one, right? This step is not horrible, is it? Just calculating these percentages. And then these two we already know. 14.2%, 14.2%. So you made a really interesting data set, Jeff. Get off my back, Jeff. All right. Is he talking to himself? Yeah, he is. So, last thing we'll do is we'll try to create this histogram, and then we'll take our field trip. All right. So, this one is going to go, like we said earlier, if you do it the textbook method, it's going to look like this. And then I can just keep adding 5 because that's the width. You do it, Jeff. Can you do it, Jeff? Oh, wait, one more. And this one, of course, is where we had to boom, boom, boom. We had to bump it up a bit. Now, if you did it the inequality method, it would look like this. You with me? If you did it the inequality method. I like it. What did these represent again? Didn't I make them something physical? What was it? Ages, right? Yeah. Ages of people in a class. So make sure you label this. And what's going to go here? Well, I haven't told you yet. I could ask you either to make a frequency histogram or I could ask you to make a relative frequency histogram. So let's make a relative frequency histogram. That's the one we normally work with. So what should be a good scale so that all this shit fits? I got to go up to, would I go up to 100? Why is that silly? Because then my histogram be this little tiny thing. I want to go up to 50. And so I can figure out my scale. What's a good scale then? Go by, maybe about 10. Let's see if I can do 10, 20, 30, 40. Okay, roughly. Jeff, you're excited, man. Yeah. Real freak. All right, so you want to label both of the axes. Are you looking the right way? I need an artificially intelligent camera. All right. So how tall is this first bar? Then is everybody decent with what's happened so far? And you get to pick which way you want to do this. If you do this, I don't want to see this shit. Right? Whatever method you picked over there, you got to stick with it. So how tall is this first bar going to be? 50%. Wow. You can make your whatever sound effects you want when you do this. The next bar, of course, is going to go up to 14.2, so it's a little bit below halfway there. And then 7 is down here. And then the last 2 are back up to 14.2. Wow. More sound effects. Is that hard? No. Were there things in there that you didn't know before you know now, and that were they really hard? No, you just got to remember how to calculate class width. Stuff like that. Like it. So this is in chapter 1. This is section 1.3, making the table. This, I think, is section 2.2. Using what you did in the table to make this picture. That's why I kind of do them both at once. Makes sense to me. All right, and that's pretty much as far as I got in the other class. Any questions about that? All right, now help me out here. We're going to go on a little field trip. If you guys would exit this room going that way really slowly so that I can get out in front of you. Everybody with me? We're going to go towards the library really slowly at first. All right.